So I lectured on 2.5 today, and apparently not every student understood what I did, so I decided just to redo that lecture and explain some of the subtleties that you might not have picked up on. So each of the problems in section 2.5 is a word problem, and in order to complete the word problem, you're going to have to fill in a Venn diagram. The Venn diagrams will either have two or three circles, and will be kind of separated into regions where the circles overlap, where the circles are kind of independent of each other, and regions outside the circles. And we have to understand what each portion of the Venn diagram means, and more specifically, what the numbers the author is giving us in the problem mean, because it's deceptive. The numbers that the author gives us are tricky and intended to trick, I think. So I'm going to go through a few examples. Some of the examples they're all from the book. I think this example 1 is in the warm-up part of the section 2.5. And this particular problem talks about a gym. The gym has treadmills, and it has Stairmasters for cardio. It may have other things, but we're just talking about treadmills and Stairmasters. And they surveyed 150 members, and they asked them if they've used the treadmill, if you've used the Stairmasters. Some of the members said they've used one or the other or both. Some used neither. Real specifically, when I look at the instructions, or the little paragraph that sets up the problem, it says that 150 gym members were surveyed. If I look at the numbers that are given to me, it says 102 used treadmills, 71 used Stairmasters, and 40 used both types. If I add those numbers up, I don't know how viewable that is, but it comes up to 213 people. Well, there's 213 people represented here. There's only 150. So somehow these numbers are deceptive. So real specifically, I need to understand each number and what the author means when he gives me the number before I can go very far with this problem. This very first number that I see said 102 used treadmills. Of the 102, some used only the treadmill, and some used both the treadmill and the Stairmaster. So this is going to be semi-important that you understand that when the author gives me a number, it's maybe not exactly what you want it to mean. So when the author says 102 used treadmills, he means 100 of these 102, some used only the treadmill, and some used both the treadmill and the Stairmaster. Even though the author doesn't say that, it looks like he's just telling us how many people use the treadmill only. That's not what that 102 represents. The 102 represents the 102 people that use the treadmill, some only the treadmill, some both the treadmill and the Stairmaster. And the nice thing is that the author gives us this number. The author tells me, of the 102 people that use the treadmill, I tell you how many use the both equipment. That was 40. When I look here, that's this 40 right there. So of the 102 people that use the treadmill, 40 used both the treadmill and the Stairmaster. The rest of the 102 used only the treadmill. And to figure out how many used only the treadmill, I subtract the 102 minus 40, and I get 62. I'm going to use my calculator to do all the subtractions because earlier this morning I couldn't subtract. So that's exactly. So the 102 that use the treadmill get broken up like this. 40 that use both machines, and 62 that used only the treadmill, and they didn't use the Stairmaster. Similarly, when the author presents the 71 that use the Stairmaster, that's not the case that 71 only use the Stairmaster. From the 71 that use the Stairmaster, Some used only the Stairmaster, but some of these 71 used both the Stairmaster and the treadmill. And again, just like the treadmill, the author's given us one of the pieces that I need. The author told me very specifically that 40 used both machines. So of these 71 people that use the Stairmaster, I'm supposed to separate them. The author doesn't tell me how many used just the Stairmaster. I have to figure that out by subtracting. So of the 71 people that used only, that used the Stairmaster, 71 minus 40, 31 used the Stairmaster only and 40 used both. So real specifically, for the Stairmaster, 40 used both and 31 was the Stairmaster only. So in every one of these problems that are from section 2.5, the numbers that the author give me adds up to too many. In this case, there were 150 people that were surveyed, but when I added up the numbers, I came up to 213 people. So some of these numbers count in multiple areas. So I need to somehow separate the numbers up. So now I need to get these numbers put in a Venn diagram. Well, I don't have to, but I'm going to put these numbers into a Venn diagram to help myself understand the problem a little bit better. The author, or I presented a Venn diagram that has 4 regions: region 1, region 2, region 3, and region 4. And in words, region 1 represents the members that did both the treadmill and the Stairmaster. And that number is specifically given to me. And that number is going to be given in every problem, the number for the dead middle of my diagram. So there's going to be 40 in region 1 of people that only use the Stairmaster, or use both the Stairmaster and the treadmill. Region 2 represents the people that did use the treadmill, but not the Stairmaster. And that's not a number that was given. That 102, which kind of felt like it should be that number, wasn't that number. It's the 62 that I got when I subtracted. So in region 2, I'm going to put the 62 people that use the treadmill but not the Stairmaster. Region 3 represent the people that used the Stairmaster but not the treadmill. And again, that's not the 71 that you'd want it to be. It's the 31. So that 71 was composed of 40 people that used both and 31 that used only the Stairmaster. So that region 3 that represented the people that used only the Stairmaster and not the treadmill represents 31 people. This region 4 represents people that didn't use either. And I have to subtract to figure it out. I'm going to add up how many people I've taken into consideration so far. I've taken consideration of 40 that used both, 62 that only used the treadmill, and 31 that only used the Treadmaster, and that comes up to 133 people. There were 150 people represented, so 17 of them are 150 minus the 133. So of the 150 people surveyed, 133 of them fit into using one or both of the machines. The difference between that is 17. and this is the number of people that used neither. So region 4, the region outside the circles, represents the number of people that use neither. So it's real important that you understand what each of the regions of the Venn diagram represent and understand how to get the numbers, and getting the numbers more often than not is going to involve subtracting. So I'm going to copy this set of numbers on the next page and then answer the questions. The questions, for the most part, should be reasonably easy to answer if I understand what the regions meant. So I have 62 members that use the treadmill but not the Stairmaster, 40 that use both the treadmill and the Stairmaster, 31 that use the treadmill and didn't use the Stairmaster, and 17 that didn't use either. Now I'm going to answer the question, how many didn't use either the treadmill or the Stairmaster? That's these 17 out there. There are 17 people that didn't use either. How many people that use the treadmill but not the Stairmaster? That's those 62. I've basically answered these questions as I developed the Venn diagram. How many use the Stairmaster but not the treadmill? That's the 31 people that are in this region of the Venn diagram. And then, how many used one or the other or both? So D should say, how many used only the treadmill, not that that's hardly readable, or only the Stairmaster, or both. That's what the author's asking me. Find anybody that's used at least one of the machines or both of the machines, and to answer D, I have to add those figures up. Those 62, 40, and 31 people represent a person that's used one or the other or both machines, and if I add those numbers up, I've added them up right, they come up to 133. So that's everything that's necessary to do example 1. Example 1 in some sense is friendly because there's only 2 circles in the Venn diagram. It's easier to do Venn diagrams with 2 circles than it is 3 circles, and we'll do some of each. So the next problem that I picked up was a physical problem from the book. If you had your book handy and you open your book up to section 2.5, this is problem 4. And I'm basically going to do the same sort of thing. The context is completely different. This is a problem that talks about toothpaste and not cardio equipment in a gym. But the idea, how I'm going to solve it, is going to be the same, and how the numbers are presented to me is going to be similar too. So as I read through this problem, it talks about a drug company. It's manufacturing a new toothpaste, and they're trying to give 2 flavors of this new toothpaste, a regular flavor and a mint. They surveyed 120 people, and I found out how many liked regular, how many liked mint, and how many liked both. I have the same issues with my numbers that I did in this problem as in the last problem. If they've only surveyed 120 people, if I look at the numbers that were given, the 74 that liked regular, the 62 that liked mint, and the 35 that liked both, if I add those numbers together, I get 171 people. There's only 120 in this survey, so these numbers represent more than I want them to represent probably. So the author's using, I don't know that it's trickery, but the author's making me work for the numbers that need to be given in this problem. So the first number that I see 74 that liked regular. Of the 74 that liked regular, some liked only regular. And some liked both. It doesn't look like that's what the author's trying to say, but that is definitely what the author wants me to understand. That 74 represents people that liked only regular and some that like regular and mint. And real specifically, when I look at the problem, the author tells me how many liked both. There were 35 people that liked both. So if I subtract the 35 from the 74, and I go 74 minus 35, I get 39 people. So the 74 people that liked regular are broken up into two categories. This adds up to 74 people. 39 liked only the regular, 35 liked both. So these 74 people had 39 that liked only the regular and 35 that liked both. Next number down, the 62 that liked mint. Of the 62 that liked mint, some liked mint only, some liked regular and mint. So for the 62 that liked mint, I have to realize that the author means some liked only mint, but others of these 62 liked both. So I need to separate the 62 that liked mint into the subcategories of some that only liked mint or some that liked both. And again, the author tells me how many liked both. 35 liked both. So to separate the 62 into the portions that it needs to be separated into, I'm going to subtract 62 minus 35 and get 27. So the 62 people that liked mint get broken up into 27 that like only mint and 35 that like both. Those two numbers, 27 and 35, will be how the 62 people are broken apart. So I'm going to say here, for the mint, 27 liked only mint, and 35 liked both. I'm going to throw these numbers in a Venn diagram because it's going to help me answer the questions that are posed here. So I'm going to construct a Venn diagram. There's only two types of toothpaste, so I only need two circles. I need one circle for the regular, and it doesn't matter if I make the regular on the for the left or the right circle, and one toothpaste for the mint. So those are my circles. The region in dead center represents people that like both. So in the middle of the two circles, I'm going to put the 35 people that liked both types. For the rest of the regular circle, I'm going to put the 39 that liked regular only but didn't like mint. For the rest of the mint, I'm going to put in the 27 people that liked mint only but didn't like regular. I'm supposed to have 120 people surveyed. If I look at the numbers that I have in my circle so far, I have 39 plus 35 plus 27. All of those people liked at least one, possibly both of the flavors. But that only comes up to 101 people, and there's 120 people surveyed. So the difference between the 120 people that were surveyed and the 101 people that are taken into consideration in one of these circles is 19. If you subtract 120 minus 101, you get 19. Those are the people that don't like any. So it's always going to be the case when I construct a Venn diagram, if I take all the numbers I put into the Venn diagram, it has to add up to the total number of people. When I fill in a Venn diagram, I fill in the middle of the circles first, and then I work my way out. So now I have my Venn diagram complete. It shouldn't be that hard to answer the questions unless the author asks questions that were really tricky. So the first question is how many liked only regular for part A? That's those 39 right there. For part B, how many liked only mint? That's the 27 that's in the mint circle, kind of by itself. And how many liked either one or both? That's the 39 that liked only regular, the 27 that liked only mint, and the 35 that liked both. So liking one or the other or both, liking only regular, only mint, or liking both. If I add those numbers together, I just added it up there, that's 101. So the answers to the questions for example 2 are 101 for part C, 27 for part B, and 39 for A. So in general, the 2-circle problems I think are easier than the 3-circle problems, but the idea is going to be the same. When I get a problem that has 3 circles, I'm going to fill in the dead center, and then I'm going to work my way out. There's just more regions to fill in. And every region, other than the dead center, I'm going to have to get by subtracting. There's only one number in the problem for any of the word problems in section 2.5 that I can take and put it in the table how it's written. The rest of the numbers I'm going to have to subtract to get the numbers. So the next example is another example that's in the text. I think it's before the homework problems, and it's talking about people that wanted to go to Hawaii, Las Vegas, or Disney World. And I surveyed 125 people. Same sort of deal here. If I added up all the numbers of people in this list, there's 68 plus 53 plus 47 plus 34 plus 34 plus 26 plus 23 plus 18. That adds up to 303 people. There were only 125 people that were surveyed, or potential customers that were surveyed. I can't just take the numbers and blindly throw them into a Venn diagram. That's just not going to work. So what I'm going to do is I'm going to separate these numbers by figuring out how to break these numbers up. And in order to do this, I'm going to look at a Venn diagram, and I'm going to look at this Venn diagram, and from the middle out, try to figure out what the regions are. And quickly, so I can have this available, the regions that I need to deal with in this particular problem and there's 8 of them. There's an Hawaii circle, a Disney circle, and a Vegas circle. And there's 8 regions. The first region that I'm going to concern myself with is this region 5. And this region 5 represents people that want to go to all 3. It's the only number that I know. It's 18. Every other region that's marked isn't a region that I necessarily know. Well, this is odd. As I read this, I think these Roman numerals are slightly messed up. I'm going to call this region 1, this region 2, this region 3, 4, 5. This should be region 6 for what it's worth. This region 2, hopefully I can figure out how to fix this numbering. A friend did this for me. I really don't know how to make these Venn diagrams via word. Region 2 represents people that want to go to Hawaii, they want to go to Las Vegas, but they don't want to go to Disney World. And that's what I'm going to focus on next. This region right here is region 2. And region 2 is I want to go to Vegas, I want to go to Hawaii, but I don't want to go to Disney. When I look at my problem, you think that this right here, that these 34 people go in region 2. That's not correct. This is deceptive. Those 34 people that are given to me aren't going to break up like you want them to break up. So I need to look at that 34 and kind of understand what that 34 means. So this 34, the 34 of the 34, some want to only go to Hawaii and Las Vegas, but some want to go to all 3. To Hawaii, Las Vegas, and Disney. Even though it doesn't say that, that's what the author wants me to understand understand the problem to mean. And I know how many want to go to all three. There's 18 that want to go to all three. The author told me there's 18 that wants to go to all three. So even though it looks like these 34 only want to go to Hawaii and Las Vegas, that's not the case. Some of the 34 are okay with going to all three. Some only want to go to two. To figure out how many want to go to only the two places, I'm going to take the 34 people that are okay with going to two or three of the places and subtract out the 18. And so there's really only 16 that want to go to only Las Vegas and Hawaii, even though it looks for all purposes like there's 34 that only want to go to Hawaii and Las Vegas. That's not the case. Of the 34, some are okay with going to all three, some only want to go to two. And so the 18 that want to go to all three are included in that 34. So this region 2 is going to represent 16 people. I could actually write. So that region's going to have 16 people. The next thing I'm going to look at is one of the other overlapping regions. This region right here, which is region 6, that represents people that want to go to Hawaii and Disney. But in that region 6, you don't want to go to Vegas. And when I look at that, it feels like that 23 is the number that needs to belong there, because there's 23 that want to go to Hawaii and Disney World. That's not the case. That 23 is a deceptive number. That 23 represents, so this 23 that says Hawaii and Disney represents some that only want Hawaii and Disney and not Vegas. But it also represents some that are okay with all three. And I know how many that are okay with all three. There's 18 that were okay with all three. So of the 23 that were okay with going to Hawaii and Disney, 18 of them were okay with going to all three. 5 of them would not want to go to Vegas. And I get that by taking the 23 that were okay with going to exactly 2 or all 3 of the places and subtracting. So there's only 5 people, and 5's not a number anywhere on the list, that would only go to Hawaii and Vegas and not Disney. So region 6 stands for these 5 people that would go to Hawaii and Disney and not Vegas. Now I'm going to look at this region, which was numbered as region 4, and that's Disney and Vegas. If I look at Disney and Vegas, I see these 26. That's not there. That's not a number for there. That 26 that says 26 wish to travel to Disney and Vegas, some of them are okay with going to all 3. So when I see this, 26 wish to travel to Disney in Vegas, that gets separated to some that will go to Disney in Vegas and not Hawaii, and some that are okay with going to all 3. Disney, Vegas, and Hawaii. And just like the last 2 regions, I know how many are okay with going to all 3. That's 18. So of these 26 people that are okay with going to Disney and Vegas, 18 of them want to go to all 3. If I subtract 26 minus 18 and get 8, 8 of those 26 don't want to go to Hawaii. They want to go to Disney, they want to go to Vegas, but they don't want to go to Hawaii. So this region 4 is an 8. So there are 8 people in region 4 In this particular case, it's going to Disney, going to Vegas, but not Hawaii. So I'm working my way up. I've dealt with the 18 people that want to go to all 3 destinations. I've dealt with these people that will be at 2 or 3 destinations. Now I'm going to work my way up to the 47, the 53, and the 68 numbers. The first number that I see here, 47, that wish to travel to Disney World, that doesn't mean they only want to go to Disney World. They at least want to go to Disney World. They may want to go to Disney World in Hawaii, but not Vegas. They may want to go to all 3. They may want to go to Disney and Vegas, but not Hawaii. So this number 47 gets broken up a bunch. So the 47 that want to go to Disney, it gets broken up into people that only want to go to Disney. And it gets broken up into people that want to go to Disney, Hawaii, but not Vegas. It gets broken up into people that want to go to Disney, Vegas, but not Hawaii. And it gets broken up into people that want to do all 3. So it's not specific. That 47 people that want to travel to Disney World, I don't know anything other than they want to go to Disney. I don't know whether they want to go to Disney in Hawaii, but not Vegas, Disney in Vegas, but not Hawaii, or Disney, Vegas, and Hawaii. But I certainly know how many people want to do all these things. The people that want to go to Disney in Hawaii, but not Vegas, are these 5 people. The people that want to go to Disney, Vegas, and not Hawaii are those, I can't hardly read that, Disney, Vegas, Region 4. I can't even read my writing, so let me recalibrate that. Region 4, Disney. Oh, that's supposed to be an 8 right there. Hardly looks like an 8. Sorry about that. So that's an 8. So there are 8 people that want to go to Disney and Vegas and not Hawaii. And there are 18 that want to travel to all 3. So of the 47, I've already taken into consideration 5, 18, and 8. 5 plus 18 plus 8. I've already taken into consideration 31. So of the 47 people that want to go to Disney, 31 of them want to go to other places, either 1 or 2 or other places. The other 16, 47 minus 31, want to go to Disney only. The rest of the circles are going to fill in the same way. So ultimately, I get to the point where I don't try to understand the author's. If I try to fight the author and take his words literally, I'm going to fight myself. Generally, I fill in the very middle, and then I subtract to get the other regions. So the next 2 regions that I need to fill in are the people that want to go to only Hawaii, the people that want to go to only Vegas. And I can start writing all this down to try to specifically say this is what the author means. That's getting to be overkill. When I go to fill in the region that says only Hawaii, I look at the word that says only Hawaii, which is this 68, and I subtract anything else in that circle. So when I go to do the only Hawaii, I'd like to subtract everything that's in that circle. This region 5 was supposed to be 18, because those are the people that wanted to do all 3. So the number that goes in the rest of the Hawaii circle, there's 68 people that wanted to go to Hawaii. Of the 68 people, 5 wanted to go to both Hawaii and Disney, but not Vegas. 18 wanted to go to all 3. 16 wanted to go to Hawaii and Vegas, but not Disney. If I add those up already, the 18 plus 16 plus 5, my calculator tells me that this comes up to 39 people. So of the 68 people that wanted to go to Hawaii, 39 of them wanted to go to Hawaii and to 1 or other 2 places. I'm going to subtract the 68 minus the 39, which makes up the rest of the Hawaii circle. So the Hawaii circle has 4 parts. It has the parts Hawaii and Disney, but not Vegas. The all 3, the Hawaii and Vegas, but not Disney. I'm going to subtract the parts that are in there already from the 68. And I'll go 68 minus 39, and I'll get 29. The rest of the Hawaii circle is going to be 29. I'm going to do the rest of the Las Vegas circle the same way. The Las Vegas circle needs to have 53 total people. There's 53 people that want to go to Vegas. Of the 53, I've already taken consideration a bunch of them. I have the 8 that want to go to Vegas and Disney, but not Hawaii. The 18 that are okay with going to all 3, and the 16 that want to go to Vegas and Hawaii, but not Disney. So I've already, of these 47, of the 53 people that want to go to Vegas, I've already taken care of a lot of them. 8 plus 18 plus 16. I've already taken care of 42 of the 53 people. So of the 53 people that want to go to Las Vegas, 42 of them want to go to Vegas in another place. If I take 53 and subtract the 42, that's only 11 people that want to go to Vegas only. So now I have my Venn diagram mostly filled in. I know exactly how many people want to go to each destination, but I don't know how many people don't want to go to any destination. What I'm going to do is I'm going to take all the numbers in any and all my circles and add them up. So the numbers that I see are 29, 5, 16, 8, 18, another 16, and another 11. When I add those up, I get how many people want to go to at least one place. So 29 plus 5 plus 16 plus 8 plus 18 plus 16 plus 11. I get 103 people. So there were 103 people of the 125 that would go to 1, 2, or 3 of the destinations. The difference, the rest, 125 minus 103, 22 people don't want to go to any of those destinations. So inside the circles, there are 103 people represented. When I take the 103 people and subtract that from the 125, I get 22 people that have to live outside the circles because they don't want to go to any of the destinations. So it's real structured. I figured out exactly what the circles need to contain, working my way from the middle, the 18 people that wanted to go to all 3, and then I took the sentences that had 2 destinations, subtracted that number, the 34 minus 18, 26 minus 13, 23 minus 18, to get the rest of that particular circle. Then I went to the words that only had 1 destination, and I subtracted anything that was in its circle from it to get the rest of the circle. Now I'm going to answer the questions. The first question should be easy. How many didn't want to travel to any? That's the 22 that's out here. How many want to travel to only Hawaii? That's the 29 here. How many want to travel to Disney World in Vegas but not Hawaii? So that's Disney, Vegas, but not Hawaii. That's this region, which is supposed to be an 8, but it wasn't really readable. How many want to go to Disney World or Las Vegas, but not Hawaii? Look at the difference between these 2 questions. The answer is going to be different. And is very restrictive. And only counted the 8 people that wanted to go to Disney and Las Vegas, but not Hawaii. The or counts more people. These 16 people that wanted to go to Disney, but not Hawaii, count in an or. The 8 that wanted to go to both count in an or. And the 11 that wanted to go to Vegas, but not Hawaii, counted in an or. So I'm looking for anybody that wants to go to Disney but not Hawaii, Las Vegas but not Hawaii, or both but not Hawaii. So this sentence D is a tricky sentence because it doesn't look like it's asking what it's really asking. The and is obvious. They want Disney and Vegas but not Hawaii. That's those 8. Disney or Vegas but not Hawaii counts the 16 that want to go to Disney but none of the other 2. The 8 that wanted to go to Disney and Vegas but not Hawaii, and the 11 that want to go to Vegas but none of the other two. So I'm going to add those three numbers. 16 plus 8 is 24, plus 11 is 35. And that's the number that belongs in the answer there. E again, E is a tricky problem because it's maybe hard to understand what the author wants. The author doesn't care in part E which location. I want to know all the people that only want to go to one destination. That's going to be the 16 people there that only want to go to Disney, the 29 people up here that only want to go to Hawaii, and the 11 people down here that only want to go to Vegas. And when I add those up, that's going to give me all the people that want to go to exactly one. And I get 56. So I'm working alone, which is dangerous for these kinds of problems because it's really easy to make a silly mistake. As if you're watching the video and you're really disturbed about something, there's a chance that I made a mistake. This example 3 should be in the text. I don't think I made a mistake. I'm not intentionally making a mistake, but sometimes you get a little just bungled by all the subtracting and adding. But I think it's probably right. But if it feels like I've made a mistake, open your book to section 2.5. Look at the beginning of section 2.5, and you'll see this problem I'm 99% sure worked out. I really should do another problem. Hopefully I left another problem. Yes, I did. So I have one more problem I'm going to do that's going to have 3 circles. And apparently this is not good to have. So I'm going to pretend like this isn't written and erase this from my web page so that when you print it out you don't see this, because this morning was confusing to a few students. I thought I deleted it before I printed it out again, but I didn't. This was just my trying to be nice, but this trying to be nice made it confusing. So this is problem 6 from section 2.5. It talks about cities, and some cities have baseball teams, football teams, and basketball teams. Some cities have all 3 sports. Some cities just have one of the sports. Some cities have 2 of the sports but not the others. And this is exactly what I need to do here, is figure out how many cities have only baseball, not football and basketball. How many cities have only football, not the other sports, and so forth. So I'm going to make a Venn diagram for the 3 sports. So this Venn diagram represents all the cities that were surveyed, and there were only 33 cities surveyed. If I add up the numbers there, those add up to way more than 33. So I'm going to have to subtract to figure out the missing regions. This region that's dead center represents any city that has all 3 sports, and there are 5 cities that had all 3 sports. So every time I go to fill in my Venn diagrams, I work my way kind of backwards. So now I have the 5 that had all 3. I'm going to start working with these numbers next, and I'm going to subtract. So the line that says 9 have football and basketball doesn't mean they only have that. They might also have baseball. So this 9 is broken up into some cities that only have football and basketball, and some that have all 3. And I know how many have all 3. 5 have all 3. So it's not the case that there were 9 cities that have only football and basketball. It's actually only 4, because of the 9 cities that have football and basketball, 5 of them also have baseball. So the author wants me to realize that that 9, even though it looks like it shouldn't be broken up between 4 and 5, it is. So there's 5 cities that have all 3 sports. There's 4 that only have basketball and football. There's not 9 cities that have only basketball and football, even though it looks that way. That 9 gets separate it between cities that have the two sports missing baseball and cities that have all three. And on my Venn diagram, the region that goes there, the cities that have only basketball and football are between the basketball and football circles, and there's a 4 there. When I go up to the next number, I see a 7 that had baseball and basketball. Of the 7, some had only those two. Some had only baseball and basketball. Others had all three. And of the 7, 5 had all three. I know that. So 2 had only baseball and basketball. So again, the numbers that are given don't represent what they seem like they should represent. This 7 doesn't represent the seven cities having only baseball and basketball. It's some that have all three, some that only have those two. 5 of them have all three. There are only 2 cities that have only baseball and basketball. And to fill that in, that's the region between the baseball and basketball circle, and that's going to be a 2. So I've done this and this. I'm working my way up to the 11 that had baseball and football. Of the 11 that had baseball and football, some had only baseball and football, and some had all three. And again, I know that 5 had all three, so there weren't 11 cities that had baseball and football. There's only 6 that have only baseball and football, because this is deceptive. When the author says 11 have baseball and football, that means that counts the cities that only have the 2 sports and the cities that have the 3 sports. And I had to separate that 11 up into the 5 that had all 3, in this case the 6 that only have 2. So I'm going to put a 6 in the region between the baseball and the football. Now I've done that. Now I'm continue working my way up. There's 15 cities that had basketball. Some had basketball and football. Some had all 3. Some had basketball and baseball. To fill in the next 3 spots that I need to fill in, I'm going to subtract what is in the circle already, because the 15 that had basketball doesn't mean basketball only. The 15 that had basketball is broken up into 4 that had only basketball and football, 5 that had all 3, 2 that had only football, baseball and basketball, and then some more. So what I'm going to do is look at the basketball circle, see how many of the 15 cities I've already taken account of. That's 4 plus 5 is 9 plus 2 is 11. There's 11 cities that have basketball plus some other sports. I've already, of the 15 cities that have basketball, I've already contended with 11 of them. 11 of the basketball cities have one or 2 other sports. So there's only 4 cities, which is 15 minus 11, that have basketball only. I'm going to go up to the football only. Look at the football circle. There's 17 cities that were surveyed that had football, but doesn't mean they have only football. 6 of those cities had baseball too. 5 had all 3. 4 had basketball too. So of the 17 cities, 6 plus 5, 11 plus 4 is 15. 15 of them had at least one of the other sports, possibly 2 of the other sports. So I need to subtract the 15 cities that have football and some other sports from the 17 cities that have football, and I get 2 cities with football only. The last region are the baseball cities. There aren't 16 cities that have only baseball. There's 16 cities that have baseball. Some of them have some other sports. There's 6 cities that have baseball and football, 5 that have all 2, 2 that have baseball and basketball. 6 plus 5 is 11 plus 2 is 13. There's 16 cities that have baseball. There's 13 cities that have baseball and some other sport. So there's 16 minus 3. Only 3 of the cities have baseball only. So I'm beginning to get the Venn diagram done. It's not complete because there could be cities that have no of the sports teams. What I need to do is add up all the numbers in the Venn diagram to figure out how many cities this Venn diagram represents. So I'm just finding every component of the Venn diagram. I see a 3, a 6, a 2, a 4, a 5, a 2, and a 4. I'm going to add these numbers up, use my calculator to be safe. 3 plus 6 plus 2 plus 4 plus 5 plus 2 plus 4. That takes into consideration 26 cities. Make sure I did this right. 7 minus 5 is 2. 9 minus 5 is 4. 11 minus 5 is 6. Good, 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 good. So there are 26 cities in this Venn diagram that are considered so far. Some have one of the two sports, some have two of the sports, some have all three. There were 33 cities surveyed, so I'm going to take the 33 total cities minus the cities that have at least one, and I get 7 cities that don't have any. Now I'm ready to answer the questions. The first question is only football. That's these two teams right there, those two cities that have only football. The next one, part B, having baseball and football but not basketball. I have to understand the region that represents. That's this region right there. Those 6 cities have baseball and football, but it's outside the basketball circle. C is hard. It's baseball or football, and it counts way more things than you might want it to count. C counts that city. It counts this city, these cities, these cities, these cities, and these cities. Any city, the only thing it doesn't count is those 4 cities that have only basketball and not the other sports, and it doesn't count those 7 cities that are missing all the sports. So part C wants baseball or football, or both baseball and football, or baseball and basketball and football, or baseball and basketball. It's counting everything of the 33 except the 4 cities that only have basketball, that don't have baseball and football, and the 7 cities that are missing everything. So if I added these up, 3 plus 6 is 9, plus 2 is 11, plus 4 is 15, plus 5 is 20, plus 2 is 22. There's 22 cities that have baseball or football, plus possibly more. It doesn't say only baseball or football. It just means basically I'm looking for any city that doesn't have basketball only, or it's missing all 3. Part D, I want to find the cities that have baseball or football but not basketball, and that's counting these. All those cities have baseball, football, or both baseball and football, or it's okay to have both, but none of those cities have basketball. So these 3 that have baseball only, we'd say those cities have baseball or football, but not basketball. Those 6 that have both baseball and football, I'd say those have baseball or football, but not basketball. And these 2 cities that have only football, it's okay to say those have baseball or football, but not basketball. I'll add up those 3 numbers. 2 plus 6 is 8, plus 3 is 11. There's 11 cities that have baseball or football, but not basketball. And the last one is exactly 2 teams. The regions for that is these centers, these circles in the kind of the middle. These 6 that have exactly basketball and football, they have exactly 2 teams. These 4 that have only football and baseball have exactly 2 teams. And these 2 that have only baseball and basketball have exactly 2. So this 6 plus this 4 is 10, plus those 2 is 12. There's 12 cities that have exactly 2 teams. I don't know that that's, leaps and bounds better than what I did this morning in class, but hopefully it's just that little extra push that helps you understand the questions. Ultimately, you can almost do these things mindlessly. Generally, the author gives us the overlapping region in the bottom, and then I'll just work my way up and subtract and subtract. There's every single number other than the number that's dead center. You have to subtract to get the number that goes in that circle. So I'm going to shut the video off. I will do, again, when I get to do the review here in a minute, I'll do the review problems that have Venn diagrams. I won't probably go into as much detail when I explain the review problems with the Venn diagrams, but I'll do a couple more Venn diagram questions. So if you're feeling like that wasn't enough review of Venn diagrams, in 5 minutes here, I'm going to start recording a video for the review, And problem 12 on the review is a Venn diagram problem with 2 circles. And problem 13 on the review is a Venn diagram problem with 3 circles. I'll do those 2 problems, so there's 2 more Venn diagram problems you can watch a video for, and hopefully that pushes you far enough and you're able to do the Venn diagram problems on the test. All right, so I'm going to shut the video off. If you watch the video this weekend and you just don't understand, kick me an email out and I'll try to answer your questions the best I can. I can certainly meet with you before the test, so I've got plenty of time to do that, so I can sit with you one-on-one to see if there's something you aren't understanding. Just send me an email, tell me that you're lost, and then I'll meet with you and then try to get you unlost.